All right, take note. This is a continuation of our float switch configuration. Okay, so where we stopped last time was linking up our switch to a contactor. So let's do that quickly. So the essence of using dotted line is because it's going to be an option. It's optional. It's not from a default setting. This connection does not come with the motor starter. It's optional and is a alteration done by someone else, not from the factory setting. That is why I'm using dotted line. But when doing the connection in a real life situation, you're going to use the size of cable that supplies this particular starter. That same size of cable that you use to supply the uh, the control panel, is that same size of cable you're going to use to supply to make this connection. Remember that here is going to be in open position, while this one will take over the control. All right. Now the flow switch is going to be installed right inside the tank. This is the flow switch. Okay. How do we activate this? So the connection will be this way. Remember that we have a contactor coil. We have a contactor coil. Remember, this is schematic. The schematic, you need to learn how to understand the logic control of symbols. So this contactor is an integral part of this coil. You know, it's not going to be this way. No, it's not going to be that way. So it's going to be somewhere else. Let me put it here, right? Okay. So this is the flow switch. Have the same power to this. Okay. Or better still, to make it more elementary, right? To make it more elementary, let me put it here. Okay. But if I'm doing that, um, I'm going to take away this. I'm going to take away this label. Let me make it more elementary so that you understand faster. By the time you know how to learn design, you know that both of them shouldn't come in the same place. In design, this particular one will go to power circuit. This one will go to control circuit side. Okay. Now, let me use a dotted line to make it more elementary for the benefit of those of us that are student or a learner. Okay, this is the coil. All right. Now the switch to activate this coil, I need a neutral supply. Remember, I have neutral here. So what I will do is to send my neutral conductor, um, taking cable from here. Let's see if we can offset this a little bit. All right. Take note. I'll make it more elementary. Okay. It's a very bad practice to combine this, but because of the situation of things, I'll do that for you. So let's take the flow switch here. This is flow switch from the tank. Okay, the flow switch coming from tank. So let me see if I can form a tank. Let's see if I no, this is dark. It's something more transparent. Okay, supposing this is our tank, and we have something like this, like cover, the tank cover. Okay, then this flow switch should be installed right inside the tank. Right inside the tank should be at the same, it will be 50%. You mount this one. Let me show you the pictorial view, okay? Now you mount this and extend the rope to be at center at 50% level. But I prefer using this product. This one is better. This one you can mount this one, the flapper will be going up and down. Mount this at the center just by the side of the tank. Now root it there. So this one is more preferable, but whichever one they can you decide to use. So this is the connection. Okay, the water reaches this level to close here and open, close and open. So the connection is this way. I take my live conductor. Sorry, I'm going to use neutral. We don't send live conductor here. You're going to use neutral. So live should come here direct, neutral come here. Take note. So um, I'm taking my power from here. Since I have it here, I can as well take from there. I have my live conductor here. So I take from here to this place. This is live conductor you're going to send to the contactor, okay? Now the neutral now is what this one is going to supply. So where is my neutral? This is my neutral, the second one. So neutral is coming out from here and go to this tank and go to the flow switch and supply the switch and now come out from the switch. Now come and feed the coil. Right, we are done. All right, now here is going to be open so that this one take over the operation. Here is going to be open. Please take note. If by mistake after this configuration here remain closed, the tank will fill up and continue to waste the water. So here will be open. Now, once here open, what happens is this. I have this supply here already waiting for this to close. So how does this close to pass this current to this motor? It will close because I have my live conductor from here to the coil already. Then I have neutral from here to the switch. Then returning of this neutral will come back to activate this coil. Once here closes, this one will get activated and here will close. Once here close, this bypass will now go through and supply the motor. So this is the connection for flow switch configuration. All right, that is this. This is the pictorial view of the flow switch. Okay, so this is the connection. Take note, I said you shouldn't use this direct to make this connection. You must interface it with a contactor, or if you have a relay with 30 amps rating, you can use it. All right. Okay. So thank you. But this one must be closed. Mind you, this one must be closed. The pump, like I said before, the pump does not come with breaker. It is something you have to buy and attach. Look at it. This pump only comes with overload protection. Now, and what does overload do? Overload is to protect the friction or resistance coming from the mechanical side of the motor. All right. Okay. So when the temperature give rise, overload will trip. Remember, overload does not trip when the pump is suffering from short circuit. Let me repeat again. Let me show you. This particular connection, overload protect the mechanical. We have two parts of this particular submersible pump. We have electrical side, that is the motor. We have mechanical side, that is the impeller. The impeller is the mechanism that has the suction part, you know, bearing, fan, suction, like diaphragm stuff, you know. So the rotating one of it is going to be the impeller. The mechanical side is the rotating one. The electrical one is the one stationary. It's going to be stationary. While the mechanical one is the one that spin to suck the water. All right. Now, when there is a restriction or friction from that mechanical part of this pump, this overload will trip. Now, this overload does not protect short circuit along this connectivity. So what protect this is that circuit breaker that I just added, this